Okay, this is Water Quality Metrics by Nicole Jones. Surface water pollution comes from point and non-point sources. Point sources are any source of pollution where the injection point of the pollution into the water source can be identified. So some examples of this would be industrial activities or sewage treatment or wastewater treatment plants. Non-point sources include runoff from urban areas, stormwater agricultural activities. These are examples of where the pollution is more widespread. It's not one specific point where you can identify that the pollution is specifically coming from. It's sort of a cumulative seeping in to the water source. Surface water pollution can also occur naturally from chemicals and compounds that occur in the environment naturally. Healthy water is healthy equals healthy ecosystems. Ecosystems are a balanced environment of organisms that interact and depend on each other for maintaining the balance of the habitat and their survival. When one element becomes unbalanced, the ecosystem can collapse. Unclean water is one factor that can upset an ecosystem. Unclean water also leads to disease and death of humans. It also is associated with reduced recreational usage and poorer quality of life for people. They're not accessing rivers and lakes because they are contaminated. It's important and necessary to study water quality for human use and biodiversity because water pollution causes waterborne diseases. When pollution can introduce bacteria and diseases into the water when the water is not healthy or the temperature drops or gets too high. Those bacteria can proliferate, contaminating the water and making it unhealthy for plants and animals and humans. It can also cause eutrophication, which is when there's too many nutrients. The algae blooms, which can reduce the oxygen in the water, killing off fish, and making the water not suitable for consumption. The reduced oxygen and introduction of foreign materials or compounds or chemicals in the water can be detrimental to plants and fish and kill them, which can result in a death and loss of a species. Also, bioaccumulation is when there's lower organisms on the food chain are consumed by that have consumed or are contaminated with chemicals, are consumed by organisms higher on the food chain, and then it just keeps going up and it accumulates in the food chain as the higher organisms feed on the lower organisms. It can also create water scarcity, increased water costs due to increased need for water purification and or desalination. If there are areas where there is no water, they may need to access ocean water and desalinize it, which is a costly process. Water quality standards are set by the EPA. It's important that we have these standards because they are needed to ensure that the water we use for drinking does not pose a health risk to the public or organisms that rely on it for their habitat. Specific metrics are set by the EPA, and these are used to calculate the quality and the health of the water for plants and animals that live in streams and rivers, as well as the people and communities that use the water for drinking and activities of daily living. These are examples in the picture of things that can be caused by contaminated water pollution, air pollution, and also soil contamination. The EPA metrics for healthy water are the pH should be between 6.5 and 9, turbidity should be below 1 NTU, preferably, but below 5 NTU, I believe, is the standard from what I could find. Dissolved oxygen should have 6.5 to 8 milliliters, or I'm sorry, milligrams per liter for cold water fish. It is a little different for warm water fish. But speaking of the Sacramento River, it needs to be colder, and so it needs more, that will have more dissolved oxygen. Specific conductance should be less than 1,000 microsiemens per centimeter. It's preferred that 150 to 500 microsiemens per centimeter is best to support fish life, and the temperature should not exceed 68 Fahrenheit degrees, or 68 Fahrenheit or 22 degrees Celsius. The explanations of the metrics. So the pH should be between 6.8. This acidic water is acidic water reduces oxygen levels, and it's not healthy for aquatic life or human consumption. Also, heavy metals are found in acidic water, which can lead to negative health effects for fish and human consumption. Turbidity should not be above that 5 NTU, and it should be below 1 NTU. High turbidity indicates that particles have been picked up or washed into the water. This can come from ash, still inorganic or organic matter, algae, dissolved compounds, clay, stormwater runoff, erosion, as well as algae blooms are sources of high turbidity. And then dissolved oxygen should have 6.5 to 8 milligrams per liter. Lower temperatures, water can hold more oxygen, so it's that we want that lower oxygen for the healthy fish and other aquatic organisms. And specific conductance looks at when compounds are dissolved in water, their negative or positive ions are dispersed in the water, and so specific conductance shows those ability of those ions to conduct electricity. So high specific conductance means that there's high levels of ions that have dissolved in the water, and that may be from unhealthy chemicals or compounds. And the temperature should not exceed 68 degrees. We need a low temperature. Many fish can't survive at higher temperatures, and the morbidity rate of is higher at higher temperatures. So it needs to be below that 68 degree. Also, when water temperature increases, that is where bacteria and algae can proliferate. The metrics used in this study are the pH, that tells that acidity. That also does the turbidity. I also looked at temperature, which also affects that dissolved oxygen levels, and the specific conductance. The measurements that I got were that dissolved oxygen in the past 30 days had a mean of 9.98 milligrams per liter. This indicates that the level of dissolved oxygen exceeds the level set by the MPA. This was the one that was found on the USGS website, and then this is my time series graph. It was kind of cool to see how similar they were. And then the temperature was 56.3. This meets the standards. Sacramento has a higher or more stringent standard because the salmon population needs the water to not exceed 56.6, and it's very well regulated because of the dams in Oroville and Shasta specifically. They have to make sure that they're letting out enough water to maintain that low degree of temperature. So it's kind of a thing here in California. So this shows that it does meet those stringent standards set by California Water Board. This is my water temperature graph. Very similar. Specific conductance, I got 133 microsiemens per centimeter. That's less than the 1,000. So again, it is below the limit indicating compliance. My time series graph, very similar. Turbidity shows that it should not be above 5.0. Testing indicates that it falls within those EPA standards. However, it's not within the best parameters. There are a couple outliers there that might have tweaked the data a little bit. Here's my time series graph. The pH was 7.6, which is right there within the standards. Their graph, the one I created, which is very cool. It's very similar. Altogether, the analysis shows that the water in this area does meet EPA standards. And the application of the Safe Drinking Water Act protects the water in this watershed, enabling the EPA to set standards for pollutants in the drinking water that are naturally occurring, as well as man-made pollutants. The procedures for monitoring and maintaining healthy water are also assigned to the EPA to set and regulate. And as stated in the statute, it applies to public water. It specifies the contaminants, and it specifies the maximum amount, as well as determines techniques and treatments that are needed to reduce the level of contaminants if they are found to exceed the criteria that sets. Again, this application of Safe Drinking Water Act and of the application of the Clean Water Act protects the water in this watershed by setting those standards to restrict the discharge of pollution into the watershed. And it accomplishes this through prohibiting the discharge of pollution, and it sets and maintains the standards to control the watershed from industrial activities, requires permits for discharging pollutants, as well as funds sewage treatment plants and planning to restore polluted waters, as well as continue to maintain point and non-point pollution. And these are my references. Thank you.